This is a video from the Exam 4 review. We're going to take a look at problem 3. Suppose we have the summation from n equal 1 to infinity of x minus 2 to the n divided by n squared plus 1. I want to determine the interval and radius of convergence. So let's apply the ratio test. So I'm going to look at the limit as n approaches infinity of. So wherever I see an n, I'm going to pop an n plus 1 in. And so I get x minus 2 to the n plus 1 divided by n plus 1 squared plus 1 times. And then I get n squared plus 1 divided by x minus 2 to the n. And remember, this is all in absolute value. So this is the limit as n goes to infinity of. Now I get x minus 2 to the n times x minus 2 to the first divided by n squared plus 2n plus 2 times n squared plus 1 divided by x minus 2 to the n. But if you notice, the x minus 2 to the n's cancel, right? And what we get on the next page is the following. We get the limit as n goes to infinity of. I get x minus 2 times n squared plus 1 divided by, and then I get n squared plus 2n plus 2 in the denominator. But this is equal to the absolute value of x minus 2. This series converges when the absolute value of x minus 2 is less than 1. But if the absolute value of x minus 2 is less than 1, then negative 1 is less than x minus 2 is less than 1, right? And then if I add 2 throughout, this says 1 is less than x, which is less than 3. Now, we have to check the endpoints. So I'm going to plug in x equal 1 into the original series. And when I do, I get the summation from n equal 1 to infinity of negative 1 to the n divided by n squared plus 1. Now, what we can do is say this series converges by the alternating series test. So we need to state why the series converges or diverges. For x equal 3, we have the summation from n equal 1 to infinity of 1 over n squared plus 1. This series converges. And there's a couple of choices here, but I'm just going to say that the series converges by the integral test. So the integral test works, comparison test works, limit comparison test works. There's a few tests that will tell you why this series converges. My interval is 1 to 3. My radius is 1. And that'll conclude this video for the Exam 4 review, and we did problem number 3. Thank you.